Now that we know some control structures, it's time to put together a program that will use them. Let's look at what happens when you drop the lowest midterm grade, a strategy my students always seem to be in favor of. First off, here's the problem statement. Write a program to calculate your grade in a class. There are 5 midterm examinations worth 100 points each. You're going to drop the lowest examination, and the others are equally weighted. The grade structure will be that if you get 70 or over, you pass, and if your grade is below 70, you fail. So the first thing we need to do is create a class. So we'll open Eclipse, create a project, create a class, create a main method. These are all things we've done before. So here we're going to open Eclipse. We'll choose our default workspace. We'll create a new project. Which I'll call Midterm Grades. Remember, spaces are legal in project names. And now we'll create a new class. Now when I create the class name, notice I can't put the space between midterm and grades because that isn't legal. I'm going to have the computer create public static void main. If you're not proficient with that yet, do it yourself. Don't let the computer do it until you're sure you know how to do it on your own. Now, as usual, Eclipse has made a mess of this code. So I'm going to adjust it right away to the way I like it. Let's get their little comments out of there. Get the curly braces in order. And go back to the PowerPoint and grab our problem statement and put that in the code. That is such a handy thing to have around, we don't want to live without it. So I'll start the comment, paste, and there we go. We're all set up. The next thing we want to do is choose our method signatures. Now, I like to think about the methods first when I'm designing programs because that keeps the code better organized. Some people like to write big, long main programs and then break out the methods later. But I find that tends to get messy and disorganized and tends to make it bigger and more complicated than it needs to be. So what we're going to do is look for small, self-contained tasks that we can group together in a method. So the inputs to the subtask will be the parameters, and the single output will be the return type. Local variables are for details that can be hidden inside the method. And remember, we want to hide as much as we possibly can. So let's find a method. There's several possibilities. Reading in the grades would be one possibility, calculating the grades would be another, and interpreting the calculated grades as pass or fail would be a third. Now we really need to think this through before we just start hacking away at code. We've got a problem if read in grades becomes a method, because at this point we don't know how to store the things that we read in. And so what that means is if we read them in one method, we won't have access to them. So that isn't going to work. Calculating the grades has the same problem. So if we're going to create a method, we're going to have to both read in the grades and calculate the grades in the method. We can't separate them out. As far as interpreting the calculated grades as pass and fail, well, that would be an okay method. The only thing is it's only going to be 2 lines long. In general, we don't make 2-line methods, particularly when all they would contain is one if statement. You can do it, but usually we don't. Because it takes 1 line to call a method, you don't really get much efficiency from that. So what our method is going to have to do is read in and calculate the grades, and what should be returned is the grade. So let's create the signature for the method and write a stub. Remember that when you're writing methods, they are outside of the main program. Now all of our methods at this point are going to be public and static. The return type is something we might want to think about. So if we calculate a grade, do we want to return an int or do we want to return a double? Well, I've been teaching for a long time, and I can tell you darn well better return a double. Because if you cut off somebody's half point on a grade, believe me, they're going to be emailing you the next morning. So double is our return value. Our method name will be read and calculate grades. And we'll have to think about our parameters. There are a couple of different ways we could do this, and both of them are okay. If we put our scanner in the main method, we'll have to pass it in as a parameter so we can use it here. In fact, let's do that to get some practice with parameter passing. First, I'm putting in some curly braces around the method to calm down Eclipse. The other thing I'm going to do is I'm going to put in a return statement. Now, this is something called a stub. That is not actually the value I plan to return, but it does keep Eclipse quiet so that I don't have the little red X's distracting me from doing my job all the time. Here's our scanner in the main program. Now we're getting the little underlines again because we haven't done an import statement. Scanner is in the java.util package, so we import java util scanner. And we can now call this method. Now, if you think that I'm really being odd about calling this method before we've ever written it, don't worry, it works just fine. So let's create a variable called calculated grade and assign it from read and calculate grades. Now, the other thing we talked about is the fact we're going to need to use our scanner inside read and calculate grades. So that becomes a parameter. Now, I'm going to call it something different in the method than I called it in the original program. There's a good reason that I do this, and that's to point out to you that they don't have to have the same name. If parameters and arguments had to have the same name, they'd be completely useless. So let's give it a different name for some variety. Now you'll notice the main program now has the method name underlined in red because we haven't put the argument in yet. The argument is input. One thing that confuses beginning programmers is a lot of people want to do this. They want to go scanner input. Because the parameters, which is scanner keyboard down here, have a type and a name, it's tempting to want to do that in the arguments too. But let's think about it a little bit. Without scanner in front of it, do we know what type input is? Well, of course we know what type input is. We declared it right up there. So there's no reason we have to put scanner there. And in fact, as Eclipse was telling us, it's syntactically incorrect. Okay. So we have our method signature and we have our stub. Remember, the stub part is the return 0.0. Now, we could even run the program at this point. You might wonder why we would do something like that. We're not going to see much from it, but it is sort of a confirmation that everything is kind of on the right track in the program. Run early, run often. The next thing we need to do is make decisions about data. So let's pick out the types for the individual examination grades, the lowest examination grade, the average examination grade, the borderline between grades, the course grade, and the scanner. Well, we've already picked the scanner, so we don't have to do that one now. The individual examination grades will definitely be an int. There are some professors that use partial points, but frankly, I think that's kind of crazy, so we're going to make ours int. The lowest examination grade should also be an int. The average examination grade should definitely be a double, because we want to keep track of those partial points of grades. Students live or die on those things. The borderline between grades is probably going to be a whole number, so that will be an int too. The course grade is pass or fail, so that one's going to be a string. So now we know what all of our data are. The next thing we need to think about is where should these data elements reside? Now, we could put them all in the main program, but remember, when we create methods, we're trying to keep our main program lean and mean, so we really don't want to do that. We want to have each variable in the smallest scope it can possibly be in. And so we're going to put the variables that can be encapsulated in our method where we're reading and calculating grades down there and put only the minimal number of things in the main method. Now this is something that students struggle with at first, is where to put the data. If you just think about the smallest scope possible, you'll usually make the right decision. Since we're reading and calculating data, we'll need an int for the next midterm grade. We will need a double for the calculated grade. I think we may already have that one. Maybe we should go and look for that. Oh, no, we didn't create that one. Now I'm going to initialize that one to 0. You'll see why in a few minutes. We'll need an int for our lowest midterm grade. And instead of returning 0, let's return our calculated grade. Now we had some other variables. Remember, there was our scanner, so it's already up in the main program, and we need our borderline between grades. So that's going to be an int. I'll call it borderline between grades, and remember that was occurring at 70. So now we've got our grades in the program. Notice the next midterm grade and the lowest midterm grade are things the program doesn't need to know about. And so we're keeping them out of the main program and hiding them away in read and calculate grades. Doing this keeps your code clean and uncomplicated, and it's a great idea. Now let's make our first try at a method. So the first thing we want to do is to simplify the method as much as possible. That lets us make sure that our parameter passing is working successfully. Then later on we can go and implement the lowest grade part. This is an important step to learn in programming, is how to create simpler problems to solve and work your way up to more complicated problems a little bit at a time. So here we are in our method. We need to think about what our control structure is going to be. Now we have 5 grades that we're going to read in, so we could just read them in 1, 2, 3, 4, 5 times. But that seems kind of silly considering that we already know about loops. So instead, let's write a loop. So we're going to need to keep track of how many times we go through the loop. So we want to loop through 5 times. That means we're going to need a counter variable. I'm going to call it count and set its value to 1. Then we'll have while count is less than or equal to 5. And right there is the body of our loop. One thing it's a good idea to do right when you create the loop is to do count equals count plus 1. I cannot tell you how many times I have forgotten to put that in. If you don't put that in, you'll get an infinite loop. In fact, we might want to experiment with that right now and see what an infinite loop looks like, because sooner or later you are definitely going to program one of these. So, here's what happens when you run an infinite loop. Nothing. Now, you might think everything's okay here except for one little thing. Do you notice that little red box there? That is actually the little button that you push to terminate a program. The fact that it's red means that your program is running right now. So right now my computer is going absolutely crazy running a loop that's doing absolutely nothing. How you stop the program from running is doing that. So the way that you identify an infinite loop in your program is that that little red button stays on and that your program isn't spitting anything out. Now, if we had put system out println in the middle of the loop, we would have seen that. But very often, the loops that are running so many times are ones that don't have output in them and that you can't see. It's very obvious when one that has output is in an infinite loop. In fact, let's do that too. So we'll have it print out something clever, and we'll run it. And as you can see, it's flying by. So again, we stop with the little red button. Now I hope you don't print out too many infinite loops in your life, but I've certainly written a few of them, and I imagine you will too. So there's the basis for our loop. So the first thing we want to do is to read in the midterm grade. So next midterm grade equals keyboard.nextInt. Now one thing I didn't do there before was I didn't prompt the user. If we don't tell the user what to enter, they really don't have a clue, so that isn't fair. So let's system out print line, enter the next grade. Now notice I didn't say the first grade here because this is a loop, so it's going to be repeated 5 times. If I said enter the first grade, we would see enter the first grade repeated 5 times. That wouldn't look good. So instead I said enter the next grade. Now we know our calculated grade is going to be our calculated grade plus the next midterm grade. If we return calculated grade at this point, what we're going to see is the sum of the 5 midterms. That may not be what we want. So let's instead divide by 5. Now you probably remember that division tends to get us in trouble in Java. So let's think for a minute about whether we really want to divide by 5 or whether we want to divide by 5.0. Calculated grade is of type double. And so we definitely want to be dividing by 5.0 because we're returning a double. If we left the 5 in there, Java would promote the int to double. But remember, we're always trying to communicate as clearly as possible. And so that really should be a 5.0. Let's go up to our main program and print out our result so that we'll be able to see what's going on. The average grade was plus calculated grade. So this is a way that we can check that our parameter passing and returning is working properly. This is a great time to check it before the method gets so complicated with the dropping the lowest grade. Here are some easy grades to average. All of my students get this, by the way. All hundreds. The average was 100.0. Looks good to me. Obviously not very rigorous testing, but that's okay. We might run it one more time just to be good sports. What if we did 100, 90, 80, 70, 60? Now, before I hit return, I want to think to myself what I think that answer is going to be. I think the average grade is going to be 80 because that's the one that was in the middle of those. And the average grade is 80. Notice if you think first, you're not tricked by the computer giving a number and you just assuming that it's okay. When you just assume it's okay, then you're really not testing anything. So now we're ready to implement the real method. We've chosen the control structure. It definitely needed to be a loop. And we've written some code for that. We've even tested a little bit. But what we haven't done is dropping the lowest grade. So let's go and do that part. So we know we have to do something in the loop. And we're going to have to think about it a little bit before we just jump ahead to writing code, giving us a little more space to work. If we start the lowest midterm grade at 0, when we get inside of the loop, we're going to have to do a comparison to whether the current grade is lower than the lowest one. Well, since presumably professors aren't giving out negative grades, or at least the nice ones aren't, we need to think of a different strategy because nothing is going to be lower than 0. So instead, we need to start the lowest midterm grade at the biggest number possible and then move it down. Now, there is an integer that's available for this. It's called integer.maxValue. This is something you wouldn't have known about from the reading so far because we haven't encountered it yet. But what that is basically the biggest integer there could possibly be. That way we know that the first grade is going to be lower than that integer and the code's going to work. Once we've gotten the next midterm grade, we want to see if next midterm grade is smaller than lowest midterm grade. If that's true, then we let the lowest midterm grade equal the next midterm grade. Eclipse is unhappy right now because I forgot a capital G. And it is now placated. And I see I added an extra parenthesis in too. Okay. Now we don't want to subtract out the lowest midterm grade right now inside the loop, because if we do that, we'll subtract it out every single time. So that's going to take away a lot of points that students earned and that they deserve. So instead, what we're going to do is subtract it out after the loop is over. So we will do calculated grade equals calculated grade minus lowest midterm grade. That takes the lowest one out of the formula. Now there's one other thing we better change, and that's that we can't divide by 5 anymore, because now we've only had 4 grades in our formula. So let's divide by 4. And we're now ready to run. Whoops, and I just made a mistake. I typed return when I didn't mean to. That can mess things up, so let's just start the program over. Enter the next grade. Let's go to 100, 90, 80, 70, 60. Now in this case we're going to be dropping the 60, so what we're going to average is 100, 90, 80, and 70. So what's our average going to be? Well, I think our average is going to be 85. And there it is. Good. Program's looking good at this point. We can test some easy cases like all the midterms being the same, but that really isn't enough. So we want to test some harder cases. We've already tested the case where the midterms have different values. One case we should test is having the smallest value in each position. Have it first, have it second, have it third, have it fourth, have it fifth. That turns out to be really important. Now the other thing I noticed in my next test case that we identified is that we haven't actually finished this program just yet. Because remember, we were supposed to figure out whether the student was passing or failing based on the average. So we better go back and do that. That's going to be in the main program. So students always want to know their average grade, so we certainly want to show that on the screen. And now we're going to say if calculated grade is less than borderline between grades, we need to system out print line, say something nice to students. I'm sorry, but you failed the class. Otherwise, system out print line, congratulations, you passed the class. So let's run our now finished program. So let's do our 100. Then maybe 60, then 70, 80, 90. The average grade was 85, which we agreed on earlier, and it says you passed. The one case that we definitely want to check is what's happening right at the borderline. So let's think of some clever test data that would check that. Suppose you had 5 69s. Then the average would be 69 and you would have failed the class. If you had 4 69s and 1 70, your average would be 69.25 and you still failed. If your average was 69.5 on the other hand, my students would have wanted to pass. So these are the test cases we want to examine next. Let's do all 69s first. We're expecting to see failure here. The average grade was 69. You failed the class. So I'm poking right around the edges because that's the place where things tend to go wrong. Now let's put in 170 and 4 69s. Average was 69.25. You failed the class. That's actually correct. Enter the next grade. So here we're going to do 2 70s and 2 69s. I'm sorry, 3 69s. Uh-oh, we've got a problem here. The average grade was 69.5, so we know our average grade is being calculated correctly, but it's showing that you still failed the class. So let's think about this for a minute. Our borderline between grades was at 70. So if your average is 69.5, we don't have this quite right. There are a couple of different ways we could fix this. One way would be to change the borderline between grades to 69.5. The other way, and by the way, if we do that, we'll also have to change it to a double instead of an int, because 69.5 is not an int. The other way we could fix it is to fix it here in the if statement, to recognize that we're not going to cheat students when they're half a point away. Both of these are reasonable solutions and both could work, but I think this one maybe is a little bit more clear. So if the calculated grade is less than the borderline between grades minus 0.5, and notice that I'm using less than here, not less than or equal to. That turns out to be really important on these things. So we think we have a solution here. Now something like that is really confusing to look at if you go back to the code later, so let's put in a comment so that everybody knows what we're doing about. The minus 0.5 has to be used to avoid having students with grades of 69.5 failing the class. It never hurts to add in an extra comment. We're going to run our same program again and see if we've got things fixed now. So we're going to do a 70 and another 70 and then 3 69s. Your average was 69.5 and now you're passing the class. Now it's just as important that we not pass people in the class who didn't get the right grade. So let's look at what happens when you have 170 and 4 69s. 69.25, sorry you failed the class. Remember, when you change the program, all of the test data you've used before doesn't count because you're running a different program, and so just because it worked before doesn't mean it works now. So you actually have to go back and run it. Now, if you're wondering how they do this in industry, they actually have quality assurance people who do nothing but continuously check that all of these cases are running correctly. I'm awfully glad I'm not one of those people, but some people really love doing that. One of the problems that happens a lot in loop are off by one bugs. It's very easy to repeat a loop too many times or too few times, particularly, for example, to repeat it 4 times instead of 5 or 6 times instead of 5. So that's something you always want to check for. One of the easy ways to make sure that you don't write off by one bugs and loops is to look at one of the Java idioms. So let's go and take a look at our program and see how we wrote our while loop. Our while loop is down here in the method. And notice that I started count at 1 and I stopped it at less than or equal to 5. That pair of operations works really well. Start at 1, stop using less than or equal to. The other pair that you'll see a lot is starting at 0 and ending at less than. Now, I'm not saying that every loop works correctly that way because it doesn't, but most of the loops do. And so if you follow those idioms, you'll have fewer problems with off by one bugs. You still need to test for them very carefully, though. So careful testing is still going to be our main strategy. As far as a really good strategy, one of the things you can do is try having the loops repeat 0, 1, 2, and 3 times. If all of those numbers work, things tend to be right. When the repetitions get larger than 3, it's too easy to get off by 1 when you're counting the test data, and then your test data doesn't show whether your program is actually working.